Okay, so let's get started. So the first section I'm going to explain is the message padding, in which I first of all and this is not required. So for the message padding, what I'm doing is taking a string here as a parameter, and then I create an array, an empty array, and traverse every character in the string. Then every character I transform it in this binary form using the OR function and the bin, and splitting it by 2 in every 2. So on the and then on the conversion, I will do the length of the bits and keep adding it on the extent in its int form then, and I will attach it to the empty array, and it will traverse every character in the string, and it will deliver the string with its padding length. In this case, I for the output, and the text is ABC, which is required on the document, and it's with the string, and this is the bits of the string, which is exactly of the textbook. So then for the second, it's mixed, but I will explain all. So for the SHA-512 algorithm, I simply discovered this library hashlib, which contains already the secure hash algorithm of 512 bits. So simply I initiate the constructor, call the library, and then specify that the secure hash algorithm that I want is 512 bits. So then I update the message with its string, and then I print the hexadecimal value of hash code of this text. So it gives me this, and it may be different from the textbook, because and this algorithm I read that it does a different random seed for hackers. For the hackers do not attempt to attack on these algorithms. So, but it's 512 bit hash code, and I knew it because when I print the block size, it's of 128 bytes. So it's a total of 512 bits, because in each byte there are 8 bits. So for the f function, for the f function, for the round function, I do I discovered a blowfish cipher, which it encrypts 64 bit words in each block. You deliver a block, and which is instantiated here in the block using the urandom module from OS, and I specify that I want to encrypt a block of 8 bytes, which is 64 bits, and then what I simply do is take the ABC text, and then I encrypt the block in 8 bytes using this text, and then I decrypt it using also the one integrated in the blowfish module. Then I insert the block is equal to its plain text to assure that it's the same length. So then I print the ciphertext and plain text, and it gives me the hash code, which is the current one. For the then what it's done, it's the f function. It was the round function, then it's the f function. The f function, I try to encrypt it and do the encryption, but it was not successful. I was trying to provide a a good demonstration, but it wasn't successful. So for the last one, I will explain the message schedule, which when the message schedule will take a block message of 124 bits, and then it will do an array of 8 and 8 length of 8 64-bit words. So basically I define two functions. One to take the string to convert it into its binary form, taking the string and joining it to its binary form to convert it in format in 8 bits, and I'm traversing every character in the string and taking its Unicode value for it to convert it to binary. And then I use this function from string to binary inside of the message schedule. So basically I define a global variable of 8 to define the block size, which is of 8 bytes, which 8 bytes is equal to 64 bits per block. And I define a counter with an empty string, and I will split it into the idea of message schedule, which is an array of 8, which is defined here, of the block size, and splitting the block of 124-bit into an array of 8. It will traverse from 0 to 8, depending on the length of the message. But the message, we know it will be according to its bits, not of its length, but it will traverse per each block. And then for the hexadecimal value, that will be the same as the textbook. So I define the counter for summing each of the hexadecimal values in the message. Each block will take its hexadecimal and define it. So the sum of all will be all of it. All of it is 16. The 8 8 64-bit words in its hexadecimal value. So I return the hexadecimal, the counter, and then the message, so you can view the block of each 64-bit. So thank you very much.